Okay, so these next 2 weeks, we're going to start talking about aviation hazards. So everything you have learned up until now in the course has been designed to give you an understanding from the meteorological perspective of why these hazards occur. And from that, hopefully give you a better observation of if you know why, maybe you can anticipate where. Maybe you can even discover where ahead of time, or where if you start running into things that are hazards, how you might be able to avoid them or how you should react in those situations. So, this week's lessons, these 2 weeks, are about turbulence and wind shear. Two very common problems that aircraft face. So, what is turbulence? Say you have a hot cup of coffee in front of you and you pour some creamer into it. Did you ever watch all the swirls that take place in that creamer? All those swirls are redistributing that mass that came in with the creamer. And that the redistribution of mass is a turbulence. So if you can see that and how complex that looks, just to look at it, that's what we're trying to forecast when you have turbulence that you're flying aircraft into or through or trying to avoid. So every aircraft is different, so they handle turbulence differently. Every pilot's ability is different. Some are going to be able to handle it a lot better. Uh, One of the problems with turbulence is there's not a lot of observations. There's not an aircraft everywhere in the sky to say, oh, we're running into a turbulence in this area, or we have wonderful flight in this area. I mean, there's a lot out there, I admit that, but there's still some areas that are missed. And sometimes, some ground based radars can pick out a few things, can infer an area that might have turbulence, but really, there's not a lot of use for it. So now that we've said all the complexities of it, what are some types? Well, let's take a look at low-level turbulence. This kind of occurs in the boundary layer. Remember, the boundary layer is basically the area that's mixing from the sunshine, heating up the bottom of the atmosphere. If you were to look at one of the soundings today, we'll say, and there's really no boundary layer here, you can see. No mixing whatsoever. This is a morning sounding. So let's go back to last evening's sounding and see if we can actually look at a nice. Okay, right here, Oklahoma City. Notice the dry adiabatic lapse rate right here. So this would be the boundary layer. So if you're flying into Oklahoma City, this layer, basically a little bit below 4,000 feet or so, is mixed. And that is going to be your low-level turbulence area, the area we're talking about with this. So what are some issues with low-level turbulence? Well, you have mechanical turbulence. Say you have strong wind blowing across even a flat terrain like in the plains. Friction is going to cause that wind to begin to develop eddies or circular patterns that if you looked uh, across in the horizontal, you just see these rolls of clouds that might develop out there. They don't happen all the time. Sometimes you got to anticipate it a little bit, but that's where turbulence is. It's caused by the friction between the wind and the land. Another one, maybe you have objects that are blocking the wind in the low levels. Another mechanical turbulence. Have you ever stood between two tall buildings, say in Manhattan, or I do it down at the beach sometimes when I go down to the ocean front. There's a number of tall, very tall hotels down there. And if you get in between them, sometimes you're going to get a channeling of the wind between them. The wind's much stronger in that area than it is on either side, away from the buildings. So what happens is that there's a lot of turbulence, a mixing right going on right in that area. Again, so if you have big mountains you're flying between or whatever, maybe these are areas you're going to get some mechanical turbulence. And mountains are a problem for turbulence. Think about it, a wind going across the Appalachian Mountains. You live right by them. If you have strong east winds at Beckley, that wind had to come across the mountains, and it's going to want to go up and down. It's going to take a little bit to settle down. So when it's doing that, say you were flying in from the west, you'd begin to hit these bumps. And as you get closer and closer to the mountains, these bumps might get stronger and stronger depending on the wind and depending on the stability. So if you're flying into this turbulent pattern, you want to understand that the closer and closer you're going to get to the taller mountains, the more your turbulence is going to be. So you've got to decide, is it getting too bad? Do I need to veer off to the left or the right away from the mountains, or run parallel to them till I maybe get away from where the worst wind is coming through? You're going to be making those decisions as the pilot. Another one in the boundary layer is thermal turbulence. This one's really, we can look at it very quickly today on a observation. We'll just look at a nice image. It's over the Gulf of Mexico I wanted to look at to show you the thermal turbulence here. It should come up in a second because I had it a minute ago. But what it is you'll see a lot of bumps and a lot of cumulus clouds. If you're down in Florida sometimes, here you go. Notice all these bumpy cumulus type clouds. So if you were flying across the Gulf of Mexico or into, say, South Florida down here, you're running into a lot of small cumulus clouds that are showing up. This is convection, and it's turbulent. It may not be strong turbulence, but there is some there. So if you're flying in a small aircraft especially, you might be bouncing around some. I've flown into Orlando sometimes in big jets, where as it's coming in and we start descending into Orlando, there's the morning Q field that's developed, the cumulus clouds all over the place. We start dropping into that and you start bouncing a little bit. And as we would go through one cloud, we bounce, we go out of the cloud, we go down, we go back into the next one, we bounce a little bit. It wasn't bad, but it's turbulence, just like we were talking about here. Another one, as we go on through these lists of possible ones, here's frontal turbulence. The other day, we had a very strong cold front go through. You had it in West Virginia. We had it here in the east. It's even down all the way into Florida now. That cold front was extremely steep. So if you were moving along with it and flying into it, you would be crossing into the cold air, even at a low level, moderately low level, very quickly. So your air is being pushed up very strongly there. A lot of turbulence with that kind of feature, especially out ahead of the front. The front just acts like a bulldozer. It's bulldozing out that warm air. And think about when you see a bulldozer working the ground or whatever, you see the dirt getting pushed up out ahead of it and rolling over. Same effect is happening to the air almost. Sometimes you can watch a front and see how fast they're moving by looking at wind gusts behind the front. You looked at the other day, that front was moving about 30 miles an hour or more, maybe even up close to 40, and there were wind gusts behind that front of around 35 to 40 miles an hour. So it gave you a good approximation of the wind, of how fast your front is moving. Another area is thunderstorms. Any thunderstorm is going to have turbulence. The stronger the thunderstorm, the more turbulent it is. That's why all aircraft are pretty much told to stay away from thunderstorms, because the amount of updraft in a thunderstorm, a very strong thunderstorm, can sometimes exceed 100 miles an hour. And I don't think any aircraft wants to hit an area with air going up at 100 miles an hour, and then outside of that area, the air might be going down at 100 miles an hour. If you get into that situation, you're in major trouble. So, clear air turbulence. Well, let's take another look back here. We'll close this out. And the National Weather Service Aviation Weather Center actually tries to forecast all types of turbulence and relates them to. Here's some observations. We're going to talk about SIGMETs and all, and AirMets more in this course as we go along. But you can see here's moderate turbulence. And you can see it coming down out of Montana here and up through the Midwest here. A lot of turbulence reports actually in Missouri, Illinois area. Well, if you actually look at that area, we'll go back here a second, and we'll look at upper air maps. Montana, well, look at that. There's a jet there. Missouri, the jet's curving and is even stronger. So where there's a jet, and especially where it's turning, there's going to be a lot of turbulence. So many times they're going to ask you to fly below that level or above the level of where the most turning and most turbulence is. So you can see Aviation Weather Center actually picked up on it, and the reports even show it. So it's right in here. So it gives you something to think about. It gives you a way of knowing where that turbulence is. Mountain waves, we've talked about them some before. You can really see them after a cold front passes in the Appalachians. You'll see these Q lines all the way rolling over. And it's just very bad turbulence as you go across that area, especially if there's any kind of really cold air aloft making the air unstable. If that happens, you can really get jostled in your plane flying around. The other one we're going to talk about is wind shear. Wind shear is an issue in the sense that you're going to change your airspeed as you fly through a level that has wind shear. So, microburst, typical wind shear, they occur with thunderstorms, very small thunderstorms, but you might get a lot of wind coming down in them. So say you had a rain shaft at the end of a runway that's pointing towards the runway. It's maybe moved. It looks like a pretty steep angle on it. If you're flying a plane into that area, you're going to be hitting wind coming out towards you as you're flying up. It's going to help your lift. But as soon as you pass through that, your wind's going to be going away from you, and you're going to begin to come back down. And that's your wind shear. So microbursts are definitely a big problem. And many times rain shafts are one way of checking it. Another one might be that you'll see some dust getting stirred up at the end of the runway or around there somewhere it's been dry. These are usually very short-lived events too, so the airplane in front of you might not have had a problem with it. You might be the one that has that problem. So you've got to be alert if you have towering cumulus clouds, even beginnings of heavy showers developing around an airport, because they're going to be a low-level event. If you're flying up at 30,000 feet, you're not going to have a problem with microbursts like this. Detection of them right now, a lot of the big airports, say Orlando, say Washington National, Washington Dulles, many of the big airports have what they call terminal Doppler radars. They scan at the lowest elevation of 0.3 degrees. I've brought up the radar topic to you in this course. It's up to you whether you want to talk about it. But you can actually see at that lowest elevation, you can actually pick up these beginnings of microburst and give you a chance at detecting them and avoiding them. Frontal wind shear is going to be where there's really strong, sometimes very strong wind shear at the low levels. Say you have a warm air mass that's moving towards your location. I have seen instances where at 2,000 feet there's a 70 knot southerly wind. At the surface, It's still in the cold air. So the surface actually might have northeast winds, maybe 5, maybe 10 knots. So not very strong. If you took an aircraft off, you're going to fly to the north into the wind, and within 2,000 feet, you're going to encounter a 70-knot southerly jet. How's your aircraft going to react to that? So you've got to be aware of that kind of wind shear, understand it, and be able to deal with that in your flight. Finally, at night, sometimes there's cold air, wind shear, just maybe mountains draining down, uh, possibilities like that. So let's just take a quick peek at one of those instances here. We'll look at the soundings. We'll do it this morning. And there's not a lot, to say the least, around the area today. So here's a little bit. Here's your bound. You have no boundary layer basically anymore at Wilmington. At nighttime, it's cooled off. But your low-level winds, it's probably a local effect, are out of the south, while your winds just off the surface are westerly. So there's a small degree of shear there. So it's just something to think about and be aware of. So I hope you got something out of this week. Remember these. If you have questions, please don't hesitate to ask.